Recording for Zach. I think this is Zach. Okay. We are on 10-4, and we're doing the second half of 10-4. Okay. Shh. Okay. No commentary. We got to listen. We are on page 536. Okay. And we are talking about normal distributions. This is one of my favorite things to talk about and teach. Okay. Normal distributions. Something that is normally distributed has an average in the middle, and then it's like tapered off on either side. So like if I'm looking at a histogram, the majority of my people, or like a frequency table, the majority of my people are going to be average. Like let's say the average test score is an 80, right? Most of my people are scoring an 80. Then there's some people up above here that are in like the 95 range. There's some people down here that are in like the 65 range, whatever, right? Okay. But this is how this works. Okay. Most people are in the middle. That's why my tallest tower is in the middle, right? Okay. So I'm going to give you numbers that go along with this. Off to the side over here, write this stuff down. Let's say X bar is, let's go ACT scores. Let's say the average ACT score is a 20. We'll make this easy, right? Ooh. Average ACT score is a 20 with a standard deviation of 4. We'll make it big. We'll go 4. Okay, standard deviation of 4. That might be about right, actually. X bar is 20 with a standard deviation of 4. Okay, here's how we label our bell curve. Ready? Your average goes in the middle, and they call it mu. I call it X bar. It doesn't matter. Those both mean the average. And I'm going to put a 20 here, okay? Now, on a bell curve, we have different like cut scores, okay? And your cut scores are based on what your standard deviation is. So I did the average of 20 and a standard deviation of 4. So what we do is we start with 20 in the middle and we do increments of 4. If I do an increment of 4, this number up here would be 24. The next increment of 4 would be a 28. The next increment of 4 would be a 32, right? Okay. Now if I go back down the other direction, this would be a 16, 12, this would be a 12, and this would be an 8, yeah? Okay? Now, usually we just do 3 numbers on either side because most of the time that's going to cover just about everybody. That's not to say you can't score above a 32 on an ACT, but you are going to be in the very, very top percent, and I'll talk about what percent is in there, all right? So here we go. This is something called the empirical rule. There was a guy way, way, way back when that studied data set after data set after data set, like hundreds of data sets, and he found that within all of those data sets, if you calculate the average and you calculate the standard deviation and you set up your increments like we did here, that about 68% of your people would be one standard deviation away from average, right? One standard deviation would be like between 16 and 24, right? 4 on either side of 20 would be 16 to 24. About 68% of your people would live in that range, right? So about 68% of people who take the ACT, if these are true results, and again, I made these up, but if that's the true average in the standard deviation, I can assume that about 68% of people who take the ACT are going to score between a 16 and a 24, right? Now, in addition to that, he did some more calculations and found that 95% of people are going to score 2 standard deviations outside of the average. So 2 standard deviations were the numbers 12 and 28, right? That's adding 2 on this side and 2 on this side, right? 95% of your people, if this is real data, are going to score between a 12 and a 28, right? Then 99.7% of your people are going to score between an 8 and a 32 because that is 3 standard deviations outside, right? 20 is in the middle. I subtract it 3 times and I add it 3 times. 99.7% of people are going to be between an 8 and a 32. So what happens if you are above a 32? You are in the 0.3% of people that are outside of that main middle range. You are like the 0.3, actually, it's really 0.15 because it would be 0.15 on this side also. 0.15% would be below an 8, and 0.15% of people would be above a 32. Now,
you almost have to know the answers to get below an 8. Like you
a lot of people have argued that, like, yeah. Actually, we were talking about that last period, actually, and Daniel Wirtz was saying, because I said, what if you just go through the ACT and you just straight line bubble, right? like there's 5 answer choices on the math section, so you have a 20% chance of getting the answer right if you straight line bubble,
You
right?
get like a 9.
20% of 36, because 36 is the highest you can get on ACT,
gosh.
is about a 7. So if you straight line bubble on the ACT, you should get about a 7 or an 8 in the
Or-
math section.
Or a 20.
Whatever.
you
So
get Z,
really,
if you
if you absolutely guessed the whole way through, you should at least get like a 7 or an 8, probably. Okay?
Did you know somebody
So
says C
you have to be really unlucky to get below an 8, probably, on the math section at least, right? Because I think maybe the English section only has like 4 answer choices instead of 5. So maybe it's easier. I don't know. Anyway, so that's how that works,
all the way
okay?
through and
So,
they get 20.
breaking this down also, we can look at, let me erase some of this stuff, okay? Let's look at some of these other intervals in between, okay? I can look at this and I can say, okay, what percent of people scored above a 28? 2.35%. And actually, this should be, because I think above a 32 is like 0.15 is above a 32, right? So what is above a 28? It would be 2.35 plus the 0.15, right? So what percent of people is above a 28? 2.5 total, right? What percent of people scored between a 20 and a 24? 34% of people. What percent of people scored below an 8? 0.15%. What percent of people scored between a 12 and a 16? This is going to be the type of stuff that you're going to be doing today, right? They're going to give you the average. They're going to give you the standard deviation. You find your numbers, and then you look at the chart and tell about what percent of people are doing whatever, right? Okay, got it? Okay, let's talk about this guy. Okay, this is assuming that your data is a normal distribution. Write that down. Normal distribution. Okay? Normal distribution means it's symmetric. It's following that bell-shaped curve, right? But what if it's not a normal distribution? Like we've talked about like the left skew and right skew before, and I've told you about how like I don't agree with it because the left skew is actually on the right and the right skew is actually on the left, whatever, right? What happens if you have data that looks like this? This says the data set is blank. What is this normally distributed?
Right skewed.
This one is right skewed, okay? Because most of the towers are on the left side. You remember how I talked to you about how it's the opposite? It's like where your foot is, right? Okay? That's a really tall big toe. Anyway, this is right skewed, okay? So thus the data can or cannot be approximated with a normal distribution.
It can.
It cannot. It cannot be or can't be approximated with a normal distribution. You have to have your data be symmetric in order for it to do the bell-shaped curve thing, right? Okay? All right, here is where we're going to get into information. Example 5. A normal distribution has a mean of 42 and a standard deviation of 6. So what I want you to do down here in the corner, draw the best bell-shaped curve you can. Draw the best bell-shaped curve you can. Okay? And what number goes down here in the middle? The average. What is the average?
14.
42. 42. With a standard deviation of 6. Okay, so let's add 6 and subtract 6. If I add 6, I get 48. If I subtract 6, you get 36. Okay, let's add and subtract 6 again. So if I add 6, I get 54. If I subtract 6, I get
30.
30. Okay, let's do one more. If I add 6, I get 60. If I subtract 6, I get
24.
24. Okay, now, do you remember what percent was within one standard deviation?
68.
68. What was the next percent?
98.
95. And what's the last percent?
99.7.
99.7% of people are going to live in that range, okay, if this is the data for whatever scores, right? Okay. This is asking the question, find the range of values that represents the middle 95%. What two values are the middle 95%? From 30 to 54. That's all they're asking, right? From 30 to 54. That's it.
Easy.
Easy. Okay? All right, now it asks, this might be a little bit more difficult. What percent of the data is greater than 36? Let's find where 36 is. 36 is this guy right here. So I want to know what is bigger than 36. It might be easier to figure out how much is less than 36, okay? So you guys might have to flip back to your bell curve, right? Okay, what percent would have been between 30 and 36? I think it was like 13.5, right? What percent would have been between 24 and 30? 2.35, and what's below 24? 0.15%. Okay, so what percent would be below this whole thing? If I add those all together. 16%, right? 16% would be below a 36, so what would be above a 36? 84%. Now you can go through and you can add all of these percentages together, whatever, right? But it might be easier to subtract. Okay, so 84% of your data, that would have been part B. What is greater than that is 84%. Okay, what percent of the data would be greater than a 36? 84%. Questions about that? Yeah, I like this stuff. Okay, all right.
We're done. No more.
Okay, last thing. Oh, gosh, I don't want to do that. Last thing. All right. The last thing has to do with a z-score. Okay, and this is another one of my favorite things to teach, all right? So here we go. Here's my bell curve, right? Okay, and let's say we go with the data that they have here, example 6, okay? They say mu is 19, which is another way of saying your average. So let's say the average ACT score is a 19, right? Okay, and the standard deviation, which is another way of, like this little guy is called sigma. Okay, that's what he's called. He's a Greek symbol sigma. Okay, he's sigma. That's what he is, right? Okay, and 3.8 is what he is. Okay, so that means we add 3.8. Adding 3.8 would be 22.8, right? If I add 3.8 again, I get, I don't know, 26.6. If I add 3.8 again, I get 30.4. Okay, now help me subtract. I can't subtract very well. Subtracting 3.8. Is it 3.8? 3.8? What do you get?
15.2.
15.2. Okay, subtract 3.8 again. 11.4. Check that. Subtract 3.8 again. We get 7.6. I don't know. So do that again for me. Yep. Those are my three numbers on either side, right? Okay.
Yep.
All right. Now here's the deal. When we start talking about a z-score, okay, here's how this works. If my z-score is 0, that means I got a 19 exactly. If my z-score is a 2, that means I got a 26.6 because a 2 standard deviations above average, that's where I'm located at, right? What if I got a -3? I would be at a 7.6 z-score, right? Okay, but here's the problem. Okay, you're confused? Okay, 0 represents average. That means I'm on average, right? Okay, if I have a z-score of 1, that just means I'm 1 standard deviation above the average, so I am at a 22.8. If I have a z-score of 2, that means I'm at 26.6. If I have a z-score of 3, that means I'm at 30.4. If I have a z-score of -1, that means I'm 1 standard deviation below average. So I'm at a 15.2. This would be a -2. But here's the problem. What if my score was a 21? Yeah, what if I'm at a 21 instead of a 22.8?
Then it's a decimal.
How do I figure out what my z-score is?
You divide by your. I don't know.
I would divide.
What he said.
22.8 minus 21.
Nope, you're on the right kind of track.
Wait.
How far is that away from average?
2.
It's 2 above average, right? So 2 above average, okay? And what are my units measured in?
Oh, divide by your 3.8.
Divide by my 3.8, right? Okay, so the formula is you take your x, whatever you are, and you subtract the average, which we call x bar, or mu, I guess is what they call it, and divide by the standard deviation, right? Because I am 2 above average. I'm 2 above average, but my units are measured in terms of 3.8. So what is 2 divided by 3.8? What would my z-score be? 0.52. That's what I would be for a z-score. I am 0.52 above average. I'm not quite 1 above average. I am 0.52, which is right here and kind of in the middle. Okay?
So if your number is like, what's the So if you're like 24.
Okay, so let's say I'm 24, which is what they say right here, right? We want to know if I am 24, I would be somewhere in between what and what?
22.8 and 26.
If I'm at 24, I would be between 22.8 and 26, so I would be between a z-score of 1 and 2, right? Okay, so I take 24 minus 19, and I divide by 3.8. Okay, 24 minus 19 is 5 divided by 3.8 is how much?
1 point something.
1 point something.
What the
1.3.
1.32. This is my z-score, right? Okay. Now, one more thing. I'm gonna skip that stuff. Okay. Here's what I want you to do. All right. I wish I had this information. Let's go. Okay. Hold on. Really quick. Do you guys know how tall you are?
I do.
5'8".
Who are my tall boys in here? Simon is tall, but I don't want that tall. How tall are you?
5'9".
You're 6 foot tall. How tall are you?
5'9".
You're 5'9".
5'11".
Okay. All right. Here's what we're gonna do. Listen. Okay. Here's what I'm gonna do. Ella is tall, and so is Carson. You gotta listen. Shh.
Oh, you are not.
Otherwise, this project is not gonna be very nice.
For a girl, she is.
Stats chapter 6. I gotta see where we're at. I gotta see where we are.
Colin, how tall? 5'8", 5'7".
So how'd you go from 5'9" to 5'7"?
You're doubting me.
What do you mean? What did I say?
You kept saying 5'9".
Oh. There's no way that Ella's 5'9", sorry. I believe she is. You're actually... Because she looks like it. If
Hold on.
5'9". How tall are you? Brady, how tall are you? 5'11" on the dot. Yeah, she's 5'8".
Okay, quit watching, Zach, because I'm gonna make you dizzy.
Then she's
Hold on.
You would eat a toy.
Why are you fat shaming him?
That's rude, Trevin. Imagine fat shoes. I'm 6 foot.
Where is it?
5'8.5". With my Brooks, I'm 6 foot. Yeah. With my Hokas, I'm like 5'9". Maybe, bro. Your Hokas are like...
I missed.
So like,
So it's like 2000.
but honestly, the Brooks are the best running shoes I've had.
Okay, with you. I can't find where my sheet is.
Brooks are nice. I use Brooks until this year.
Okay, real quick. Look up the mean and standard deviation for let's go teenage boys for height.
I'm legally 5'7".
Mean and standard deviation for teenage boys for height. Look it up.
Do like 50.
Mean and standard deviation for teenage boys for height.
Why are they creating so many new symbols? Like,
What do you mean? I've been kneeling for ages.
Mean and this is the same thing as X bar and this is the same thing as S.
You're not a
to
Sigma.
like a certain age.
Sure.
Yeah, let's do like 15, 16.
Okay.
16. Okay, and then I need the same thing for girls.
There's like 2 people that are 16 in this class still. More than that.
Okay, what you got?
54.8 for the mean.
For boys?
Yeah.
Boys? 54.8?
Yeah.
What, in inches
No. Is that
or inches?
inches?
Wait. Oh wait, we gotta go to height.
Yeah, I want height.
Wait, this is in
What
centimeters.
is it? Weight?
166.94.
166.94. And what else?
7.7 for the standard deviation.
Okay, give me girls. Convert those. Go.
I'm working on it. I was
166.94 centimeters to feet. Or to inches, I mean.
13.9.
What?
And then girls is 159.5.
Okay.
4.9.
Divided by 12. 160.
Okay, those centimeters to inches. Somebody convert. Hurry up.
65.72.
65.72. And what's standard deviation? 7.7.
Catch it.
I don't get what you did.
7.7.
3 inches. 2.8.
3 inches.
2.83. Okay. All right, girls. 159.5.
Why did you just rub me?
That hurt.
Okay, what are you doing, child? No.
This?
Put it away in the trash.
So the
No,
average
put it away in the
height-
trash.
for
Put it away in the trash.
16-year-old male is 5'5".
Okay, are you converting?
Oh.
Hey, you're not done converting. I need 159.5 and 4.9. Go.
You didn't say that.
Yes, I did.
What do you think the average height is for a 16-year-old male?
62. Okay.
5'5".
62.
55.72. What?
62.8.
Dylan.
Okay.
I'm nice.
And standard deviation?
So,
What the Sigma?
1.93.
Girls is
All right, here we go.
5 point.
Okay, listen up. I've got all my data now that I need. Okay, ready?
You're welcome.
This is why we do what we do. This is going to be exciting because I want to compare Ella and Carson. Okay, here we go. All right, we looked up. Shh, you got to listen. Shh, you got to listen. Dylan just looked up for me. He looked up on the same website the average for 16-year-old boys and average for 16-year-old girls for height. And they gave us in centimeters, so we converted it. Okay? The average height for a 16-year-old boy is 65 inches, almost 66 inches, so that's 5'6".
5'5".
5'5" and change, right? Almost 5'6", okay? Girls, it's about 5'3", almost 5'3", okay? With a standard deviation of this and a standard deviation of this. Okay, now, real quick. Shh, you gotta listen. Looking at my standard deviations, which one has heights that are more spread apart? Boys, their standard deviation is higher than girls. So they have heights that are varying more, depending on when you hit puberty, probably, right? Okay? And girls, you're more consistent because usually by 16 years old, you have started to slow down in growing. Honestly, that makes it really sad, okay? So here's the deal. Ready?
This hurts so bad.
This is why we want to have a Z-score. Shh, you gotta listen. We can't get to the fun part unless you listen.
What's wrong?
Sit or are you going to the office? I'm done with you running around the room. Okay, I'm done with you running around the room. Sit. Okay, no more. All right, boys and girls, we want to be able to compare them. But here's the deal. Ella is a tall girl. Ella is 5'9". Ella, how tall are you? 5'9"? 5'9" is 69 inches. Okay? Carson.
6'9".
Okay, Carson, how tall are you?
72 inches.
He is
72.
72 inches. Okay? Now, you gotta listen. You gotta listen. I want to compare those two, but it is not fair for me to compare Carson and Ella straight across the board because Carson is a boy and Ella is a girl, and it's not fair because girls are just shorter. That's just the way that it goes, right? So what we do, okay, you gotta listen. What we do is we create and we find a Z-score because I want to know who is taller relative to their gender. Does that make sense? Is Ella a taller girl or is Carson a taller boy? Okay? So here's what I need to do. Carson is 72 inches. How far is he above average? I need to subtract that, right? That's how far Carson is above average. But each unit is measured in terms of 2.83. So what is Carson's Z-score? 72 minus 65.72 divided by 2.83. What is his Z-score? You got it?
3.2.
3 point what? 3.3? 3.3 is his Z-score.
Are we really trusting the lady?
No.
No, that's not right.
2.2.
2.2?
Yeah.
Okay, you have to
Because
do this and then divide by 2.83.
6.28
That's what I did.
divided by 2.83 equals 2.2.
Brady's
Why are you talking like a hillbilly?
2.2.
2.2. Okay. So Carson has a Z-score of 2.2 because he's above average. All right, now Ella. What do we do for Ella?
Let me handle this one.
How do we calculate Ella's Z-score? Tell me what to write.
Well, you have to subtract it.
69 minus 62.8 over.
I think Carson has wider Z-score.
Okay, what's Ella's Z-score?
3.2. I agree.
Wow, you guys got that one
Okay,
right.
now, here's your question. Shh, listen. Who is taller, Ella or Carson? Just the way they are. Just the way they are. Carson is taller than Ella. Yes? Carson is 6 foot, Ella is 5'9". Who is taller relative to their gender? Ella is a taller girl than Carson is a tall boy. Yeah? Yeah, there you go, okay?
Alright, Owen, you're next.
Does this make sense?
My turn.
We have to convert it to a z-score, otherwise it's not fair, okay? They do the same thing, listen to this. They do the same thing when you're looking at ACT score versus SAT score. ACT score is 0 to 36. SAT score is like in the hundreds. Like 1,600 or something like that, right? Okay, it's in the hundreds. How do I compare the two? Because SAT is obviously going to be a bigger number than ACT. I convert them to a z-score, and then I can compare the two. Does that make sense? Yeah, because it makes it equal for both units, right? Okay,
Alright.
so that's how this works. All right, here's what I want you to do.
Let's pick the tallest boy compared to the tallest girl.
Hold on.
Simon.
I want you to, on whatever scale you are on, find your z-score. So boys, your number is going to change right here. Figure out how tall you are. Girls, your number is right here to change.
What do I do if I'm on the spectrum scale?
What do I do if I'm 6 foot?
I'm 60.
Then you will be Carson. You will be the same as Carson. Okay?
68.
All right, find what your z-score is. Find what your z-score is.
6 foot. Hey,
5'10" is 70, yes. So you'll take 70 minus 62.8 over. You're taller than Ella?
A little bit.
Nice. I didn't realize that. I didn't realize that. Okay.
also, I think
Alright.
this factors in like,
Find your z-score. Girls, you're dividing by 1.93.
Dylan,
I kind of messed it up. There you
what
go.
you should have done, you should
Scroll
have
up, I can't
asked
see
for in America.
the O.
It's right there.
Oh, 2.83.
Okay.
These are 16-year-olds, by the way. Not
All right. Yeah, these are 16-year-olds. So,
Well, good thing I'm 14.
boys, you're 72. Girls, you're replacing the 69. Okay. Simon, do you have your number? Because I'm interested to see what your number is.
He's 5'8", so.
Okay, find your number. How tall are you, Simon?
What do you think the average height is for a 16-year-old in
No,
America?
he is not.
I don't know. That's what this is supposed to be.
5'10" in America. This probably factors in.
I don't think so. I don't think that's right. Okay, Simon, how tall are you?
5. Wait. So
Guess.
I'm not on.
You're 6'7". How many inches is 6'7"?
Yeah, I thought so.
Okay, but you're still
6'7"
So short.
is 79 inches. Simon, calculate this.
Wait.
Simon,
Go up.
calculate this. 79 minus 65.72 over 2.83.
1.83.
You're 1.83?
Dylan, what are you?
I'm 2.3.
I don't think so.
What are you?
Why are you?
How tall are you?
Negative 2.3.
I'm 6'1".
6.
No, I
Dylan
don't
is
think so.
5'4". Dylan's like 5'6".
I'm 5'6".
There's nothing wrong with being negative because, you know, there has to be some people. Yes. Are you below average?
No, I'm not below average.
Are you below 6'5", 6'6"? Are you below 6'6"?
I'm
Or 5'6", I mean?
actually
5'6"?
5'6".
You are 5'6" exactly? So you're slightly above average. All right.
But if I'm...
You're growing though, Dylan. You've grown a lot this year.
Dylan.
Give me my pen.
What's up, Elder?
Dylan is below
Okay.
average.
2.
Simon, did you get a Z-score?
Yeah.
What'd you get?
Swear on God's green earth.
Woo!
Swear on God's green earth, Jacob.
Okay.
Look at it.
Did you guys all get a number?
Yeah.
You want to know Simon's number?
What?
1.69.
We only did from -3 to +3, right? Okay, because outside of that would be 0.15 on either side, right? 0.15%.
Isn't he?
He is 4.69. He is way above.
Grade art students, if you had artwork, you need to go pick that up in the gym at this time. Eighth grade art students, please pick up your artwork in the gym at this time.
Love average.
Also, anyone that had
Question,
pictures
I
in
will be
the
your
packet
picture
room
Friday.
with your
I
friend
have
up,
state
please
trash,
pick those up as soon as possible. National Honor
telling me now,
Society
so.
members, be sure to bring your items for the banquet tomorrow.
Girls, what'd you guys get for Z-scores? Anybody? 2.7, what'd you get? 0.62. You're slightly above average.
Say
Anybody
I
below?
grew 2 inches by the
You're
time
2.1. You're above. All the girls in here are taller.
3.7.
I'm
You guys are all positive.
1.83.
Any boys negative?
Yeah.
And then boys
okay.
got negative
That's
z-score?
because the standard deviation is literally.
I don't believe that. Sure. How tall are you?
5'5".
You're 5'5"?
5.
So you would be slightly negative. Negative 0 point something.
I want to check if it's
Right?
5'5". Come here, Dylan. Come here. I want to check if you're actually 5'5".
That's not
Because
Dylan.
I'm 5'8".
Boy.
Yeah, he even said so.
I'm 5'6".
Yeah, and I was like staying in
Boy, you is not 5'6", a Rooney.
Did we not measure in the weight room that one day?
We did.
I don't know.
5'6".
Who's 5'6" and Owen, how tall are you?
All right.
5'8".
Stand next to this so we can see two
Are you
inches.
really 5'8"?
Owen.
Owen, you capping.
Oh,
Owen, you capping.
What do you mean
butt
I'm
to butt,
capping?
butt to butt.
No one.
Owen's a little taller.
I don't know.
Owen's
taller,
taller.
but like.
Isn't that like?
Yeah.
There's no way Owen.
Okay, here's what I want you to do for homework in the last 15 minutes. You only have 3 problems.
This is not
7, 8, 9, 10. Do those.
That's 4. You're a math
4
teacher.
problems. 4 problems. That's what I mean.
Actually, it's more like 6 because it's an ABC.
Sure, we don't care. 7, 8, 9, 10. Do those right now in the last 15 minutes.
Why is it not turned color?
7, 8, 9, 10. Do those.
This is racist.
That's what I want to do.
Racist.
I feel